This is a neodymium magnet. It's pretty darn strong, and now, after heating it in a flame, it's no longer magnetic. What just happened? Well, to build a magnet, all you need to do is find a bunch of magnetic atoms. That's easy, they're the ones with the half-filled electron shells in the middle of any of the major blocks of the periodic table, and then make a compound where the magnetic fields of the atoms align in the same direction. This is ferromagnetism, named after iron, which is pretty darn magnetic. However, it's not always so easy. Sometimes the atoms actually want to align their magnetic fields in alternating directions. This is called anti-ferromagnetism, and it means the bulk material won't have a magnetic field at all. Or sometimes the tendency of the atomic magnets to align or anti-align is just too weak to overcome their intrinsic jiggling, that is, their temperature, in which case, even though all the individual atoms in the material are magnetic, the material as a whole, again, isn't. However, in a strong external magnetic field, the atoms do tend to align with each other in the direction parallel to the field. This is called paramagnetism, and liquid oxygen is a great example. It's attracted by a magnet, though it doesn't stay magnetized afterwards. But let's get back to the question. How do you destroy a magnet? Well, a material can only be ferromagnetic if its temperature is low enough. Above a certain point, the nicely ordered atomic magnetic fields melt into disorder, just as ice crystals melt into water when heated past 0 Celsius. So to destroy a magnet, you just need to heat it up past its magnetic melting point, called the Curie temperature. It probably won't look like much is happening, but once the atoms are jiggling around enough, their magnetic fields will no longer all point in the same direction. Magnet destroyed. And just as different elements melt from solid to liquid at different temperatures, they also melt from being ferromagnetic to paramagnetic at different temperatures, which you can explore in this sweet interactive periodic table, which also plays all the periodic table of videos.
We're going to begin with an experiment to illustrate this.
This episode of Minute Physics is supported by Audible.com, the leading provider of audiobooks across all types of literature, including fiction, nonfiction, and periodicals. To delve deeper into the stories and science behind the periodic table, check out The Disappearing Spoon and Other True Tales of Madness, Love, and the History of the World from the Periodic Table of the Elements by Sam Keen. Man, that's a long title. You can download this audiobook or another of your choice for free at audible.com/minutephysics. Again, thanks to Audible for making it possible for me to keep producing Minute Physics and for giving you a free audiobook at audible.com/minutephysics.